So we are dealing with the unit circle. And the unit circle, I don't have it in this, I don't know how to bring it in, but when you look at the unit circle, all the number that cosine and sine has are zero, meaning zero. We have 1/2, we have radical 3/2, we have radical 2/2, and we also have 1. So those are the numbers that we see on the unit circle. Good. 0.25 is 1/4. So it's not listed here. So what should we do? We are using calculator, correct? And when you see a question like this, so there are some hints. They don't ask you find the exact. So when you don't see the word exact, that means we should rely on the calculator. So on the calculator, there is a button here. The button is inverse. So x will be equal to sine inverse of 0.25. So you press the button, you put sine inverse, you look for the sine inverse. You look for the sine inverse and you plug 0.25. This gives you one solution. And make sure that the unit of your calculator is on degrees. And I'm going to ask Yvette to tell me what's the answer. What is sine inverse of 0.25?
I'm so sorry. I don't have a calculator right now. My niece took it to school.
That's okay. But make sure you have it by next Friday. Jason, did you do it?
Yeah, 14.48. I don't know if I rounded it.
Degrees, correct?
Yep.
It should sounds correct. So this is 14.48 degrees. But if you look more inside of your calculator, we don't get any more. They don't give us two solutions. They just give us one solution, correct, Jason?
Right.
But if you remember last session, you asked me, do we have always two solutions? And I said yes, but if is on the axis of, sometimes if it's on the intersection of x and y, sometimes we get one. But this is for sure is not here, correct? So we should have the second one as well. How do we get the second one?
Would it be like related to y being positive in quadrant 1 and 2? So like add 90 degrees.
Very nice. So what Jason got, let me pick. So here is 14. This is 14 degrees. And Yvette said, oh, this is a y. Very good. Also, we have same thing here for the sine. Good. So what is this angle now? How do we find that? So this one, this much, will be 180 degrees minus 14.48 degrees. So we subtract from 180 for the sine. If we subtract, we all rely on Jason today. Jason, what do we get for subtract?
We got 165.52.
$165.
0.52.
I used to do this type of calculation in my head, but so much computer that I cannot even think about it. Anyway, thank you. So we got two solutions. This is for the sine. For the sine, we subtract for 180. But if you have for the cosine, we know if, for example, cosine, if we got one angle here, if, for example, we got 35 degrees, for example, another one will be 360 minus, so one of them is theta, another one will be 360 degree minus theta. This is going to be for the cosine. Then you're using your calculator. I don't think you will have a question like this in final for sure, but I'm talking about the real life. I mean, when you're using the calculator, when you get one solution, there might be another solution. So for sine, you subtract from 180. For cosine, you subtract from 360. Why this is? The good thing about this app is I can just, we have an unlimited canvas. I can just move it, go up. Excuse me. So let me back to this. All right, we saved it. So we got the idea when you're using the, when we are using the inverse. Now let's have some tricky question, which you will see it in a quiz or exam. So back to that inverse. So I said x equal to sine inverse of 0.25. If you have an old calculator, this sine inverse, same as arc sine of 0.25. So if you have a calculator that doesn't have the inverse, this is same as arc sine. Good, this is exactly same as that. So now the question is, find this bothers me. Okay. Now tell me what is sine parenthesis cosine inverse of 1/4. This is exact value. What is this equal to? Let me change the app. This bothers me. I'm not very good at this one. Let me use this one. So the question is sine of cosine inverse of 1/4. They said exact. eval without the calculator. If you use your calculator, if I say use a calculator, so you pick this in the calculator that gives you a number, and then you find sine of that, and you're done. But no calculator. So what do we know about the inverse? We know, this is an example. This is an example. Cosine of 45 degrees equal to radical 2/2, correct? We know this. This is a fact. This is exactly same as cosine inverse of radical 2/2 equal to 45 degrees. So these two are exactly same. The meaning of the inverse. So cosine of 45 is radical 2/2, or cosine inverse of radical 2/2 is 45. So to make this story short, we learned that inverse, cosine inverse of a number, like I would say A, so the output of inverse will be an angle. So tangent inverse of, for example, B will be theta. So anytime you use inverse, the output will be an angle inside of the unit circle. Good? So we have that knowledge. So now we're gonna go back to our question, which is sine of cosine inverse of 1/4. What is cosine inverse of 1/4? Do we know an angle that cosine of that is 1/4? So cosine inverse of 1/4. That means this gives us a theta. This is exactly same as cosine of theta equal to 1/4. All right. When you look at the unit circle, do you see any angle that cosine of that is exactly 1/4? No, correct? 1/4 is not part of our deal. So what do we have here? We have cosine of theta equal to 1/4. And cosine inverse of 1/4 equal theta. So instead of this parenthesis, can I plug theta? Because on this one, I call cosine inverse of 1/4 is theta. So this is exactly same thing as asking what is sine of theta. So that's the trick. I mean, that's what we do. When we see inverse, we substitute theta, correct? Because we know inverse gives us theta. And I plug this theta for the parenthesis, I got this. So what do we have in this question now? Cosine of theta is given. We are super happy. Then they're asking us what is sine of theta. So how do we find sine of theta?
The inverse.
Cosine is 90 minus theta. for sine of theta.
So you're saying cosine of 90 minus theta equal to sine of theta. This is great. That's good. But how do we use it here?
We don't have theta, huh? So
Yeah. I mean, so this part, this type of question, write a note for yourself that in this type of question that you will see, we need to use Pythagorean. We did this before. So cosine of theta is given. We're looking for sine of theta. That's chapter 2. There are two ways to solve it. One of them algebraically, another one using the circle. Cosine of theta is 1/4. So on the first quadrant, I'm going to put theta here. Good. Cosine is x/r. So this will be 1. This will be 4. We use Pythagorean theorem to solve for y. We have y squared plus 4 squared equal to 1 squared. We have y squared plus 16 equal to 1. Y squared equal to 1. What? 1/4. No, 4. That's totally. I had something else in my mind. So did you see, guys, any problem with the Zoom link? Or everything was same as before? I'm just different topic because I see less people online. It's same, correct? You just click on the Zoom.
yeah, I mean, I have it on my calendar, so
But the calendar was there as well, correct?
yeah.
I felt like something happened, but anyway. So y squared plus 1 squared equal to 4 squared. That would be super. 16. 16 minus y squared equal to 15. Then y will be a radical 15. And it's plus. So we solve for y. Then what is sine of theta? Sine of theta will be y/r, which is √15/4. Good, we solved it. So the answer is √15/4. I know you guys didn't like it. I'm going to solve one more. I'm not going to challenge you guys something like this in the final exam, but I would like you guys to have it in your mind that if you take pre-calculus, there are techniques to find the exact value. Let's have another one. But I think you should know this for the exam. I might. So don't dislike, I mean, don't say, oh, you don't need it. But you need to know this. So another question. What is cosine parenthesis sine inverse of 3/5 plus cosine inverse of 5/13? I know this is not pretty to you guys, but solving question like this is super nice. So what's the first step? Yvette will tell us. We don't need a calculator, Yvette.
Solve the parentheses. So sine is theta and
Excellent. Very nice. Very nice. So when we see the inverse inside the parenthesis, so this inverse gives us, if it's a theta. What about this one? I shouldn't call it theta. I know it's going to give us the angle, but it's not the same. Good. This gives us like alpha. So somewhere on your notes, for example, here, you're going to write that sine inverse of 3/5 equal to theta. This means sine of theta equal to 3/5. Then cosine inverse of 5/13 equal to alpha. This means cosine of alpha equal to 5/13. What do we do? I just box it. This is very valuable for us. Good. So we have this one and we have that one. So and now I'm going to substitute for this and for that. They ask us to evaluate cosine of parentheses sine inverse of 3/5 plus that. We made it simple. Instead of the first one I put theta, the second one going to be alpha. So if we solve cosine of theta plus alpha, then we are done. So what is cosine of theta plus alpha? We see addition rule here, correct? So cosine of theta plus alpha, you go to the note sheet. The formula for this is cosine theta, cosine alpha minus sine theta sine alpha. You get it from your note sheet for the first formula that we learned for addition rule.
I have a question.
Yes, sir, Joshua.
So we're just going to ignore the inverse of like the sine inverse and cosine inverse.
So we don't use the calculator. They said find the exact. If you use sine inverse of 3/5 in your calculator, gives you an angle. And cosine inverse of 5/13 gives you another angle. If you add them and find the cosine, you're done. But is not exact. This is the way to solve the exact value. That was your question, Joshua?
Yeah, it was.
So I know you see inverse button in your calculator, but that doesn't give you exact. You're looking for exact. So now let's see, what do we have? We have equal sign here. We are looking for cosine of theta plus alpha. Do we have on this orange cloud, the sunny cloud, Do we have cosine of theta? We have sine of theta, and we have cosine of alpha. So cosine of theta we don't have. I'm going to make a parenthesis here and look for it. Do we have cosine of alpha? Yes, cosine of alpha is right there in the corner. So I'm going to put 5/13. Minus, do we have sine of theta? Yes, 3/15. Multiply by sine of alpha, we don't have. Jake, are you following me? Any question? Very nice, yeah. I know you guys don't like this. I know this is too much, so much, but when you guys just see it in details, you see we are repeating same concept, right? But your job is to just have a good note. If there is a question like this, that's how we solve it. I mean, if I bring one question like this in final exam, that means you know more than 50% of the topic of this course. Because we at the beginning of chapter, you're using everything you learn in chapter 1 to chapter 6. So we are looking for cosine of theta. Cosine of theta should come from sine of theta. I'm going to make a circle. So the first quadrant, for a question like this, if you see positive always in the first quadrant. So randomly, I'm going to make this one theta. This is 3, and that's 5. We use Pythagorean theorem. You solve for x, which is 4. Then from here, cosine of theta will be 4/5. Then you plug 4/5 here. We make another circle next to this part. I make, and so this was theta, I make this one alpha. Would be 5/13. We use Pythagorean theorem. This is y, which y will be 12. If we use Pythagorean theorem, it gets 12. 5, 12, 13 is the Pythagorean number. So then sine of alpha will be 12/13. So I'm going to plug 12/13. Then you take a break to color the flower, to just relax that you did so much good. All right. So now what do we do?
Multiply.
Yeah, this is multiplication. This is multiplication. And there's a minus between them. 4 times 5 is 20. Divided by 5 times 13 is 65. Good, I'm able to do that. Then 3 times 12 is 36 divided by 65. When you add them up, you get negative 16 over 65. So this is the final answer. Can you guys tell me why did we got minus? Again, drawing is very important, guys. Make sure you're thinking what you're drawing. So do you know why we got negative? Joshua?
Because in the formula, when it's like adding the two angles is actually negative.
Very good. That's, I mean, yeah, we didn't do any algebraic mistake. The formula has negative here. Very nice. But in picture, when you, even this theta was here in the first quadrant, and that was positive, this was positive. How come we got negative for cosine? Anybody?
Is it because we were provided the inverse up there, and so it's a negative?
Good. That
Inverse it, it's positive.
no. So this theta here, you see, is positive, correct? Cosine of that is positive. So we had cosine of theta plus alpha. Cosine in this quadrant is positive. Then we have another angle like alpha. When you add alpha and theta, when you add these two, it happens to be more than 90. It came to this quadrant. So this is alpha plus theta. And in quadrant 2, cosine is negative. That's what's happening. When you add them, it exceed the first quadrant and went to second quadrant. All right. Cool. Oh. Back to solving triangle. We went through solving triangle in like one of the exam. Now I'm asking you guys, solve for theta and x. Edison, how do we solve for theta here?
You subtract 90 by 65.
Very nice, Edison. So we are dealing with the right triangle. And the right triangle is so many formula we have for that, correct? And I mean, so many formulas. We have Pythagorean theorem. We also can use like sine of theta will be opposite over hypotenuse. So there are so many rules we have, but we try to do the basic one. The basic one is, if you add them up, we should get 180. And if you subtract from 180, this is 90, 65, and theta should be 25, correct? So theta is 25 degrees. And we're done. We get points. But how do we solve for x?
Pythagorean.
Excellent. Yvette loves Pythagorean. Yeah, if you see a right triangle, we use Pythagorean. And Pythagorean theorem said 4 squared plus x squared equal to hypotenuse squared. We have 16 plus x squared equal to 25. Then x squared equal to 25 minus 16 happens to be 9. And then x will be 3. Algebraically, we have x squared equal to 9. X will be plus minus root 9, which is 3. But because we are dealing with a triangle and the length is not going to be negative, so we don't worry about the negative part. Good. So this is beautiful as sunset, blue sunset on the boats. When we definitely can get points on this. Now let's deal with the triangle that is not 90 degrees. Like oops. This is 29 degrees. This guy is 102 degrees. We are looking for this, which is C. I'm going to call this one A, and this guy B. This is B. This is C. That's A. And B is given 28 feet. Now they're saying solve. So when they said solve the triangle, that means you need to solve for C. What angle is that? What's the measure of that? You need to tell me what is the length of C from A to B, and what is the length of A. That means you need to give everything. It looks like all of them are in feet. Now I'm going to ask Edison. Which one is easy to find here?
The angle of C.
Excellent. Angle of C is easy because if we add them, C plus 102 degree plus 29 degree equal to 180 degrees. C plus 131 equal to 180. C will be 180 minus 131. This will be 49 degrees. Correct? So we got C, thanks to Edison, is 49 degrees. Another question is, how do we solve for A or C? Anybody has an idea?
Isn't it the law of sines or something?
Joshua, very good. But what about Yvette?
Well, depending on what angle you're finding, you either use like sine or cosine. You use the length over either A or C.
I see. So definitely we are not using Pythagorean, correct? Because we are not dealing with the right triangle. So Pythagorean theorem is out. What you are saying, Yvette, this, what you said is also related to Pythagorean theorem. If, for example, this is alpha, we have sine of alpha will be, we're gonna call this one B over C, correct? Are you referring to this one? Cosine of alpha will be A over C. Good. This one, again, referring to right triangle. We are not able to do this because we learned that sine of alpha equal to opposite over hypotenuse. So we are using hypotenuse. The hypotenuse happening only on the right triangle. So this is out as well. So the good news is we have two new formula. One of them is law of sine. So I'm gonna use another layer, only talk about law of sine. Law of sine. This is same as the sine that we just know. For any triangle, any, if this is, I'm gonna call it this is A, B, C. Then the side front of it, this is going to be lowercase a, lowercase c, and this is B. Good. For any triangle, we have sine, sine of A over A equal to sine of B over B equal to sine of C over C. So this is, they call it law of sine. Easy to memorize. The way we proved that they made it like this to be easy for us to memorize. So sine of this angle, correct, divided by the length of that equal to sine of this angle divided by that one. It's not pretty. It has an easy proof as well. This is a sine. SpongeBob. Good. So now we have a formula. Let's see if we can use this formula. Are you following, Yvette?
Yes.
So we have a new formula. So that means I can say sine of so the formula has 3 equality, but when we are using it, we're going to use only 2 of them at the same time. This 2 or this 2 or this 2. That's how we cannot have 2 equal sign. So I'm gonna write like a sine of 20, sine of 29, correct? Divided by 28 should be same as sine of 102 divided by a. So sine of 29 degree divided by 28 should be equal to sine of 102 divided by a. So now we have one equation, one unknown. We cross multiply. That means this times that equal to this times that. We have a sine of 29 degree equal to 28 sine of 102 degrees. Then a equal to 28 sine of 102 degree divided by sine of 29 degree. So we solve for a. Now you use your calculator. 102 and 29 is not on the unit circle. So we need to use the calculator. We're going to say 28 multiplied by sine of 102. You get the answer. You divide it by sine of 29. Can you guys tell me what is this one?
56.49.
Let's leave it 56. So a equal to 56 feet. Edison, now how do you solve for C? How do you solve for C now?
Use the same method.
Excellent. Very good, Edison. I wish I would ask you earlier. I mean, you are following me. Very good. So sine of, we use the same method as he said. That means we're going to use law of sine. Now I'm going to pick other equation. I can keep using this one, sine of 29 over 28. So I'm going to say sine of 29 over 28 equal to sine of 49 that Edison solved it earlier. We know this is 49 divided by C. So we don't use a calculator now because we're going to get a lot of errors. So I'm going to cross multiply. That's a pretty color. Go here. We're going to have C sine of 29 equal to 28 sine of 49. I divide by sine of 29 divided by sine of 29. Our C will be this guy. Again, we're going to use a calculator right now. Jason will take care of this one. Anybody solve this?
4 for rounding up.
All right. 44 for the C. Good. So not bad. Yeah, the formula again, you have it under your note sheets. And easy to memorize it if you want. Also, we can solve. So you don't need to solve the Pythagorean theorem. Use the Pythagorean theorem for this. There is another formula left that I go over that on Monday, which is law of cosine. Good. So law of cosine will be on Monday. If you have no question, you can